Okay, let's look at the last question here, 4.3 of the circle analytical geometry. And here we go. First is a pretty easy question. Oh, you got to read it carefully. I didn't read it so carefully the first time, and I had to go and look at it again. Anyways, the circle's centered at end. Its centered at end is reflected about the line y equals x. M is the center of the new circle form. So the first thing I can think of, I've got minus 1 and 3. When you reflect something about the line y equals x, all you do is switch x and y. So there's your new center, 3 and minus 1. Okay, now if you do that, it's exactly the same circle, the same size, but it gets reflected over here. It kind of gets spun around. Imagine this red circle spinning and making the blue, and it spins on the line y equals x. That's the reflection. It intersects at A and F. Well, the first question is pretty straightforward because it just says find the distance NM. So you just put it in the distance formula. You go minus 1 minus 3, or 3 minus minus 1, and minus 1 minus 3. You get, you're going to get 4 squared and 4 squared, and you add it together, take the square root. It's the square root of 32. 4 root 2, it's 5,66 units. So there's the length. Now the next question I'm going to show, I found it pretty interesting. And I'll show you well, actually I did it all sorts of different ways, but I'm going to show you 3 of the ways. It's just sort of an interesting question. The first one says, it says find the midpoint of AF, right in the middle. Where is that midpoint of AF? Well, what I did, when I'm looking at these two circles here, I can see that from N to F and from N to A, and from AM to A and M to F, those are all radiuses. And if they're all radiuses are equal to each other, then it must be true that if all the sides of a quadrilateral equal, then it must be a parallelogram. Opposite pairs of sides are equal. It's a parallelogram. Well, we know that the diagonals NM and AF, they bisect each other. So, because that's a property of a parallelogram. So therefore, AF must just be the midpoint of NM, because they bisect each other at the same place. So you just go minus 1 plus 3 over 2, just find the midpoint of NM. And 3 minus 1, put them together over 2, you get 1, and 1 is the midpoint. But here's another way to do it. What you can do is you could go, okay, NM, do the gradient thing, go 3 minus minus 1 over minus 1 minus 4, and you get 4 over 4, but negative. You get a gradient of minus 1. And then take minus 1 and 3 and put it into the point slope formula. So x minus 3, y minus minus 1. Actually, I use this point. And minus x plus 3, you take away 2. There's the equation of the line. But the equation of the line, we kind of would like to know the equation of this line cutting across here. Actually, it might be nice to put it right in there. I'm going to change the color to, let's make it blue. That color right there, going straight through there. See, I want to find out where those two lines cross there. Well, the line AF is just y equals x. That's the line that it's reflecting by. And M is y equals x minus x plus 2. Let them equal each other. Then add, whenever you want to find out where two things cross, you let them equal each other, two functions. So you add x, you get 2x. 2x equals 2. Divide both sides by 2, you get x equals 1. Oh, that means y must equal 1. Hey, another way of doing it. And here's a third way of doing it. The y-coordinate of this f must equal the y-coordinate here, because it's just spinning around this line. The y-coordinate doesn't change. This is one way they showed about it when you reflect about y equals x. So that means that f is 3 and 3. And then the answer then the answer should be just the midpoint of A and F. 3 and 3, minus 1, do the midpoint, you get 1 and 1. So you can get this F is 3 and 3 because it's spinning around the line y equals x. You're looking at it here, you can see it has the same y coordinate. Okay, well that's it. That last question was kind of interesting. There's even more ways to do it, but I'll leave it there.